Hey guys, so in this question, you have a wire carrying a current I, and this wire is bent in the shape of an exponential spiral, that is r is equal to e power theta, from theta is equal to 0 to theta is equal to 2 pi, right? So here r is distance from the origin over here. So you have a wire in the form of a spiral, and the distance of this wire from the origin is r basically, and that r is varying with theta. Like at theta is equal to 0, your r value is equal to e power 0, so 1. At a general theta, it will be equal to e power theta. And at this point, when you complete a 2 pi rotation, your r value over here is equal to e power 2 pi, right? Okay, and to complete this loop, the ends of the spiral are connected by a straight line. So your spiral is kind of like this. Your diagram is not really great over here, but your spiral is kind of like this in this case. Your spiral is kind of like this, right? So then he's asking, so to complete the ends of this, to complete a loop, the ends of the spiral are connected by a straight wire. So this is your spiral, and your ends of the spiral are connected by a straight line. So in short, this is your current carrying spiral right now. This is your current carrying spiral. So from this we are supposed to calculate what will be the magnitude of magnetic field at the origin. What value of magnetic field I'll have at the origin in this case, right? Okay, so here understanding the question is the difficult part. I think solving this question, the approach at least is pretty straightforward. We'll say the net magnetic field at the origin is equal to sum of magnetic fields, and here dB bar is nothing but magnetic field to a small circular arc. Magnetic field to a small circular arc. So we'll select one circular arc on this loop. We'll select one small circular arc on this loop. So why are we selecting a small circular arc? Because for that small circular arc, I can say that for the small circular arc, I can say that magnetic field is uniform. Not r is uniform. Your r value doesn't vary for that small circular arc, right? And then we can either use Biot Savart or the circular arc formula to get the answer. Okay. Anyway, so for that small. So how do I select a small circular arc over here at an angle theta? And I'll go with the diagram which he has selected over here. So his angle theta is this. So at this angle theta, I'll select a small angle d theta. So this is the small element which I'm selecting over here. This is a small element which is selected. So then to find dB bar, we'll make use of Biot Savart law. So dB bar is equal to mu naught by 4 pi I into dl bar cross r bar by r cube, right? So let's worry about the direction part first. So because this is in the form of a loop, the magnetic field created by each of them at the center will be in the same direction only, right? In whatever loop cases we'll have, we'll say magnetic field to each of them at the center will generally be all in the same direction only. So here the direction of magnetic field to all these elements, the direction of magnetic field to all these elements will be in the same direction only. The magnetic field to this will be 0, so we don't even need to worry about this part because that is coinciding with the origin. So I only need to worry about what's the magnetic field to the spiral right now. Okay, so for that I'm making use of Biot Savart law, and now we know the direction is same for all of them. So what will be your value of dB? Your value of dB is what we need to focus on over here, and your value of dB will be equal to mu naught by 4 pi I into dl by r squared, right? Dl value will be equal to r into d theta, but r varies with theta here, so here dl value is basically equal to nothing but e power theta into d theta. And what about r squared? R squared will be equal to nothing but e power 2 theta. So this is what I'll need to integrate right now to find out the net magnetic field at the origin. It will be integral dB. So it will be integral mu naught by 4 pi I into dl is e power theta into d theta divided by e power 2 theta, and the limits of theta are from 0 to 2 pi. Right, so taking the constants outside, mu naught I by 4 pi are constants. We'll have integral e power minus theta d theta from 0 to 2 pi. This will become equal to mu naught I by 4 pi minus e power minus theta, limits being from 0 to 2 pi. Now substituting the limits, after substituting the limits I'll get mu naught I by 4 pi of, if I substitute the upper limit I'll get minus e power minus 2 pi, and if I substitute the lower limit I'll get minus of minus 1. So this value will basically become equal to mu naught I by 4 pi of 1 minus e power minus 2 theta, which is 2 pi, which is option number 4. Right, so hopefully this question is clear. See you guys in the next question.